In this problem, what we're going to be looking at is we're going to be looking at empirical formulas as well as molecular formulas, but with 3 different types of atoms, so carbon, hydrogen, and oxygen. And the problem reads as such: determine the empirical molecular formulas for ibuprofen, a headache remedy that contains 75.69% carbon, 8.80% hydrogen, and 15.51% oxygen. And let's see, it gives us the molar mass. So the molar mass is going to be 206 grams per mole. So we have 75.69% carbon. We have 8.80% hydrogen. And we have 15.51% oxygen. And this happens to have a molar weight or molar mass of 206 grams per mole. What we want to do is, first thing we want to do is we want to assume 100% or 100 gram sample. So if we assume 100 gram sample, then this becomes 75.69 grams of carbon. We want to take that and we want to convert that into moles of carbon. So 1 mole of carbon is 12.01 grams of carbon. And that gets us, we do that calculation, 6.302, not grams, we want moles. That's why we're doing this. Moles of carbon. We do the same thing with the hydrogen. Pick a slightly different color for that. Same thing with hydrogen. We have 8.80 grams of hydrogen. 1 mole of hydrogen is 1.008 grams of hydrogen. And that gets us to 8.7302 moles of hydrogen. Lastly, we have the oxygen. And so we have 15.51 grams of oxygen. 1 mole of oxygen is 16 grams of oxygen. We do that calculation, we end up with 0.969 moles of oxygen. There should be a 4 in here. 4 moles. Now, you see, I showed you a previous problem where we just had 2 atoms, and they essentially had the exact same mole ratio. In this problem, we have 3 different atoms. We have carbon, hydrogen, and oxygen, and they have different amounts. What we want to do is we want to divide by the smallest. So you always want to divide by the smallest so you can get a whole number, hopefully. I don't want to deal with any decimals. We may end up getting some decimals, but that's ultimately what we want to do. We may get some decimals though, but I don't want to deal with any fraction. I'm going to deal with something greater than 1. So if we take our 6.302 moles of carbon and we divide that by 0.9694 moles of oxygen, because oxygen is going to be the smallest number, so we want to divide by the smallest number. So we're going to take this number divided by, so we're going to take the moles of carbon divided by the moles of oxygen. And that's what we've done here. And when we do that, we come up with a number of 6.5. So what that tells us is that there's going to be 6.5 times more carbon in ibuprofen than there is oxygen. Okay? We do the same thing with hydrogen. We take the 8.7302 moles of hydrogen and we divide that by 0.9694 moles of oxygen. And what this ratio is going to tell us, it's going to tell us the moles of oxygen, or moles of hydrogen to the moles of oxygen. And if we do this, we come up with 9. So what that tells us, what we can discern from that, is if we have carbon, hydrogen, and oxygen. All right? By dividing by the moles of oxygen, we have set this number, the subscript for oxygen, to be 1. the carbon is, so if we have 1 oxygen, we are then going to have 6.5 moles of carbon. If we have 1 oxygen, we have 9 moles of hydrogen. This now becomes, really, this can now become the empirical formula. If you don't want to deal with the decimals, we can multiply this by 2. By multiplying this by 2, this now becomes 13. So what we get is we get carbon 13. 2 times 9 is going to be, 18, not 9. Multiply this by 2, you get that. So by multiplying this by 2, we get C 13. 2 times 6.5 is 13. 2 times 9 is 18. 2 times 1 is 2. This now, if we come up with the molar mass, if we determine the molecular weight of this, this becomes 206 grams per mole, which is the same as what we have here, and this now becomes our molecular formula. Another way we could have done this at this point, at the bottom point, I'm going to erase this so we have some more room. Another way we could have done this very easily is by determining the molar mass of the empirical formula. So if we determine the molar mass of the empirical formula by taking 6.5 times 12, the molar mass of carbon, plus 9 times 1, the molar mass of hydrogen, plus 16, the molar mass of oxygen. If you determine now the molar mass of the empirical formula, you'll come out, and when you do that, when you do the calculation for the molar mass of the empirical formula, you come up with 103 grams per mole. You can then take the given molar mass, divide that by the molar mass of the empirical formula, and you'll find out that it is 2. And so in order to go from the empirical formula to the molecular formula, because the ratio here is 2, you simply multiply the empirical formula by 2, and you would then get the molecular formula. If you have any questions on empirical formulas or molecular formulas, please let me know. I'll be more than willing to help you.